And I'm really excited about that. I feel like that is that's a dream come true. It's just really nice to be the youngest speaker at this conference. So that's there too. Then lastly, you can find me online at my website. I'll drop a link to the website in the chat. So let's talk about the agenda for today's talk. Here are the things I'm going to discuss in this talk. One, we would look at an introduction to APIs. What are APIs? Why do we need APIs? We'll take a look at the architectural styles that are available for designing APIs. A quick look at SOAP versus REST versus GraphQL. We look at tooling and setup, how to prepare your development environment. We'll take a deep dive into Articles API, which is what we'll be building. We'll look at how to create a basic server. Then I'll talk about HTTP verbs and route handling. Finally, we'll test all of our endpoints using Postman, and then I'll be down to, okay, someone says present button. I think this is the biggest, my slide. Okay, present button. Oh, sorry. Yes, let me click on present button right now. Okay, so we'll test our endpoints using Postman, and lastly, I would summarize the entire talk and listen to you ask me questions. So let's get started. What are APIs? Most people are looking at me like, well, I really don't know. You tell me, what are APIs? So an API or APIs generally are acronyms, and it stands for Application Programming Interfaces. And an API is simply a computing interface that defines interactions between multiple software intermediaries. So I'd like to explain APIs using an example. Imagine that you as a customer, you walk into a restaurant, you want to buy a box of pepperoni pizza. So you sit down at the table and the waiter comes up to you and says, oh, hi, what would you like? Welcome to our restaurant. What would you like to order? Oh, I want a box of pepperoni pizza. The waiter says, okay, I'll be back with your order in 10 to 15 minutes. He goes over to the kitchen, tells them what you want, and the kitchen works hard to fulfill your order, and in 10 to 15 minutes, the waiter brings back your steaming box of pepperoni pizza and you have your meal. So the waiter in this case is the API. He is the intermediary. He provides that interface. By making a request, you specify in what format you want the data, in this case the food you are ordering, what format you want it to get back. The API then goes to the server, tells the server what you as the client has requested, then brings back the response from the server and transfers it back to you. So here's an illustration to kind of put it all together. The client, in this case, is a laptop that makes a request. You could make a GET request, a POST request, put, delete, several types of requests. The REST API takes the request, and in this case, I was looking for a better picture, but I couldn't really find one. So rather than just being a database, what this is actually is a server. A server could be connected to a database if the database holds the data or persists the data that the server uses to return requests. So let's look at this as a server. So the API takes your request that you have sent to it using this HTTP verbs to the server. The server tries to fulfill the request, sends back the request to the REST API, and the REST API gives you back your request as either XML format, JSON format, HTML, whatever it is. Really, the REST API just sends you back. So this is what happens when you say, maybe you access the URL www.google.com. What happens is you are making a GET request to their servers through the API. So the server returns to you the HTML, CSS, and JavaScript files that you need to load up that page. And then when it gets back to you, the three files work together and you get the Google homepage. That's the basics of APIs. Now that we know what APIs are, the next question is, why would we even want to use APIs? So there are lots of reasons to use APIs, but I'll mention just three. The first one is that APIs promote abstraction. most of the times what we need as developers is simply data. We just want to retrieve data. How the data gets processed is none of our business, and really most of the time the work that goes behind the scenes into getting the data that is returned when you use an API is usually very boring, and it's just a lot of work, and we don't really need that. APIs abstract that work from with users. API simply says, okay, just tell me the formats you want me to return the data, and I will give you just that, which is very good. It abstracts all the unimportant and really boring behind the scene processes. The second reason why you might want to use APIs is that they are easily accessible. If we are looking directly at, if you are making specific reference to web APIs use HTTP protocol, which stands for Hypertext Transfer Protocol. It's just like a language that servers use to communicate with each other. And most programming languages understand the HTTP protocol, so it's really easy, accessible to use any API to get data using any programming language. That's another advantage. A third advantage is that APIs are usually very reliable. Not all companies provide APIs for whether internal or external use, but the companies that do that, for example, you can use the GitHub API to fetch data about a GitHub user, and because GitHub as a company has so many customers, so many people, millions of people depend on GitHub API to do several things. So it's usually you can access almost 100% reliability when you use GitHub API, and so it's really easy, reliable to use these APIs. There are way more reasons to use APIs, but I'll talk about just these three. So now that we know what APIs are and why you want to use them, we want to get into architectural styles for designing APIs. Generally, when architects want to design a building, there are different styles that they could use for designing buildings. You have the Baroque style, and these are Baroque kind of buildings, this pointed, I put in an image here for you to see. So this is a Baroque architectural style. So an architect could decide to go in this route when designing a building, or he could decide to go in the Gothic architectural style or the neoclassic architectural style. So in the same way, when we are trying to design APIs, there are different styles that we could use. I made mention here of about 5: the REST architectural style, GraphQL, RPC, Filecore, and SOAP. REST is what we'll be concentrating on in this talk, and it's really the most popular and dominant architectural style for designing APIs. We also have GraphQL. It's relatively new, but it has been gaining a lot of traction, and that is because, unlike REST APIs as we'll see, GraphQL makes use of just a single query to fetch lots of data across multiple resources. Other good ones are RPC, Remote Procedure Call, Filecore, and SOAP, but we won't be deep diving into these ones. So let's go ahead. So having considered what these architectural styles are, now let's talk about REST. I've been talking about REST. What is REST? Many people would think maybe REST is what just sit down, lie down, put your hat on, put on your glasses, and just chill. No, this is not what REST means. REST is actually an acronym, and it stands for Representational State Transfer. This definition was called by Wikipedia, and Wikipedia says that REST is a software architectural style that defines a set of constraints to be used for creating web services. And when you do find web services that conform to this REST architectural style, they are known as RESTful web services. So REST is simply a way or a style that defines some constraints or rules, guidelines that those services that conform to it must follow. Now this is Roy Fielding, and he's the guy who introduced REST. He introduced REST as part of his PhD thesis. when I was researching, not just for this talk, when I got to know about REST and I was researching and I found out about this guy and the fact that his PhD thesis has become what we know today as REST, I was really impressed, and it got me thinking, really now, Karen, what am I doing with my life? I really hope that in the future, maybe when I'm writing my own PhD thesis too, I'm able to work on such an interesting project like the one Roy Fielding worked on. So if you want to read more about the principles that Roy Fielding proposed in his PhD thesis that makes an API RESTful, it's in this link. I'll share that also in the chat. And by the way, Roy Fielding looks like a very handsome man. Okay. So how do we make an API RESTful? When Roy Fielding proposed REST, he put forward a set of rules and guiding principles that web developers could follow when building their APIs. Like I said before, those web APIs that conform to these rules or guiding principles are referred to as RESTful APIs. I think there are about 6 to 7 of these constraints that RESTful APIs should follow. But the two most important, at least if APIs could follow these 2 rules, then we could generally assume that they are RESTful APIs. The first one is that RESTful APIs should use HTTP request verbs, and second one is that they should use specific pattern of routes and URL endpoints. So we'll take a look at this one after the other. First, RESTful API should use HTTP request verbs. So here are the HTTP request verbs, or at least the 5 most important ones. We have the GET request, the POST request, the PUT request, the PATCH request, and the DELETE request. When we make a GET request, what we are in essence doing is trying to read data or trying to retrieve data. Making a POST request, on the other hand, sends in or inserts data. A PUT request updates data in its entirety, while a patch request updates only a part of the data. To understand, to get a deeper understanding into the differences, so sorry. To gain a better understanding into the differences between the PUT and the patch request, we could use this example. Say that you buy a bicycle from Amazon and you're so excited to start riding. Unfortunately, the bicycle gets to you and you realize that one of the wheels is removed. It's not part of the bicycle. There are 2 things you could do. You could either send a message back to Amazon, complain that, okay, I bought a bicycle and one of the wheels is removed. And in that case, Amazon can decide to send you an entirely new bicycle to replace the old bicycle. In this case, the new bicycle that they just sent is kind of like making a PUT request, because this bicycle is going to update or replace the previous bicycle in its entirety. If they don't want to do that, what they could do is to just send you an extra wheel and you use that wheel to replace the other wheel that was not present. So PUT is sending an entirely new bicycle to replace the previous one, while patch refers to sending just that wheel to replace the former bicycle that had no wheel. When we get to the coding aspect, try to bring your mind back to this example and it will help you to understand. Then finally, delete request obviously does what it says it does, which is to delete data. If you come from the database world, then these requests seem familiar to you. There's an acronym in database called CRUD, which stands for create, read, update, and delete. So create in CRUD is synonymous to post here, while read is synonymous to get. Update, put and patch together, refers to update in CRUD, while delete in CRUD is also delete right here. So that's the first rule of creating RESTful APIs. RESTful APIs should use HTTP request verbs. The second rule is that RESTful APIs should use specific routes and URL endpoints. So if you go to a Safari, you have a route for elephants, and on that route you only expect to see elephants. There might be another route for lions, for bears, and so forth, so on and so forth. In the same way, for an API to be RESTful, you should create routes and endpoints that are specific to a single or to a specific data resource. For example, if I create a route to say /articles, then making a get request to /articles route should fetch me all the articles. Say maybe the articles are stored inside a database, or you're just using an array to store them, whatever. Making a get request to that route /article should fetch all the articles. Making a post request to the /articles route, however, creates a new article that then gets added to the articles array or database. A put and a patch request should not be made to /articles because it doesn't really make sense. You want to update an article, not the list of articles. Then finally, a delete request made to /articles should delete all the available articles. This is one route /articles. We could have another route /articles/Jane-Doe, and in this case, making a get request to that route will fetch the article on Jane-Doe. A post request, you cannot create a new article inside the Jane-Doe article. It doesn't make sense. So a post request cannot be made to this kind of a route, but a push request can be made, and in which case the push request will update the article on Jane-Doe in its entirety. A patch request will update a field for the article on Jane-Doe, and the delete request to this route will delete the article on Jane-Doe. So, brief revision: RESTful API should at least follow these two guiding principles, which is 1, use HTTP request verbs, and 2, use specific routes and URL endpoints. So if that is understood, let's go build our API. Sorry. Yes, let's go build our API. This is how I feel right now, so excited. So let's go build our API. So the first thing we want to do is, I want to give a brief run through to the software prerequisites we need. We need Visual Studio Code. That is what I will use as my integrated development environment for this presentation. It's just really great. One of the great features that Visual Studio Code has is that it gives us an integrated terminal. Rather than switching between command prompt, git bash, hyperterminal, while still using Visual Studio, you can just do everything in the same place. But if you don't like Visual Studio Code for whatever reasons, you have other great options like brackets, Sublime Text, and Atom. We'd also need Postman, because with specific reference to the API we are building in this presentation, we'll only be able to make GET requests to the server using our Chrome browser. The other requests, like the post request, push request, patch request, we can't make it through our browser because, of course, I didn't create a front-end interface for this presentation. So we'll be using Postman for that. We'll be using MongoDB to save or persist all our data for the articles API. We'll also be using Mongoose, which is an object document mapper for MongoDB. Robo3t will help us to, Robo3t will provide a graphical user interface for interacting with MongoDB. Initially, MongoDB was designed to be used with shell, and it's a little bit unintuitive to use MongoDB with the shell. So the team at MongoDB created Robo3t, which makes it way easier. It provides a GUI for working with MongoDB. Then lastly, we'll use Node.js, which allows us to run JavaScript inside our code editor. Node.js also comes bundled with NPM, and we use NPM to install some third-party dependencies inside our code. So I'm hoping that everybody is still following me, and if you are, it's time to go ahead and actually build our API. So the first thing we need is to set up our server. I've just given this brief breakdown of what we need to do. Create a new folder anywhere, any directory of your choice. We need to initialize the folder as a Node.js server. You can just run the command npm init-y to say yes to all the default options. And initializing our project as a Node.js project creates a package.json file, which just helps us to monitor all the packages we install. We use npm that comes bundled with Node.js to install these third-party dependencies, body parser, which we use to pass through a request, mongoose, which I said is an object document mapper for MongoDB. It helps us to write better MongoDB code. I'm super sorry, our electricity just came back. Okay, so we'll use npm to install mongoose, body parser, and express. Express is a Node.js framework, and it helps us to write better Node.js code. So the next thing we'll do is to create a file, which will be our entry file, and we'll call it server.js, and that file will store all our server code. So let's do just that. I will open up Visual Studio right now. I already have it opened, and you can see here, this is the integrated terminal that comes with Visual Studio, and it just makes it super easy to do everything in the same place. So if I open up my integrated terminal, the first thing we want to do is to check that node and npm are properly installed. So to do that, I can run the command node-v, and that should return to us a node version. So let's see. 1 minute, please. So that returns version 14.15.0, which is really good. That's the latest stable version of Node. You can also check that npm is properly installed by running npm-v to check for the version of npm that is installed. Sorry, I need water. That should also return to us a version of npm that we have installed. So it tells us that we have version 6.14.8 installed, which is really good. Now I went behind the scenes to install all these other third-party libraries we need. Body parser, as you can see inside our package.json, I've installed body parser, I've installed express and mongoose because my laptop is really slow, and if I had to do that right now, it will waste time. And you can see right here that the main file is called server.js, and I've created that file. So inside server.js is where we are going to put in all our server logic. So let's get started. The first thing we need to do is to require the 3 packages that we installed: mongoose, express, and body parser. So I would require those packages and store them inside variables. So the first thing is express. Express. Next thing is mongoose. And body parser. Great. So now that we've done this, we need to create an instance of express so that we'll be able to use the express functions. I would create an instance of express and store it in a constant called app like this. So app is now an instance of express. Next thing we need to do is to set up our app to use body parser as a middleware to pass through our request. So body parser dot, using the URL encoded option and set extended to true. Okay, oh no. Like this. Great. So the next thing we have to do now is to ensure that our app is working. So we'll set up our app to listen on a specific port. So we'll do that by saying app should listen on port 3000, for example, and this will take in another function. And what should it do? If the app is able to listen on port 3000, I just want to console.log this message, and the message is server is started on port 3000. Great. So now to test our code, we have to run server.js file. And what is great about this, because we have installed Node, all we just need to do is to write in node server.js. But I don't want to waste time. You will notice that if you keep on writing node server.js, every time you make a change to your server code, you have to stop the server and start it again. So in order to not do that, there is another package called nodemon, and nodemon tracks changes to your server code. So every time a change is made and you save it, automatically it will start the server. So you can see right now I've used nodemon to start the server, and it tells me that the server is started on port 3000, which is really good. So our server code is working. The next thing we need to do now is to set up Mongo, set up our database. So I'm going to open up Robo3T, and here is what Robo3T looks like. Of the database. Yeah. So here's what Robo3T looks like, and here a list of all the databases that I have currently in Robo3T. But now we click on the new connection, create a database. So let's just call the database articles DB. I'll create that, and I will go back to my Visual Studio and create a schema, or first of all create a connection to that articles DB. So write something like this: mongoose dot, call the connect method, connect to mongo DB local host port 27017 / articles DB. So this is just the convention for using mongoose. When you call the connect method, this is the default URL, mongodb :/ localhost port 27017 / the name of your database. So let me save this and restart my server, and let's see if it will be able to connect. It's restarting Node. Okay, so it has connected, but we have some really nasty errors here telling me to pass this option, new URL parser. So let's just come here and add in those options. Use new URL parser, set it to true, and use unified topology, we set it to true. So once we do that and we save, let's see, it's trying to restart. Let's say restart. Great. So now our server is started on port 3000. Very good. So we have our articles DB up and running. But now we need to create a collection. MongoDB is different from relational databases which use tables. This is a document-based database. So we need to create a schema, and I'll do that by saying const article schema equal to mongoose.schema. So a schema is kind of like a blueprint. How should all articles look like? So all articles, you have a title field, which is going to be a string. and a content field, which is also going to be a string. So that is the article schema. Now we need to create a model from this schema. Let me just call my model article, and it's going to be mongoose.model articles. After we want to model these articles after the article schema. So going forward, we'll use this constant article, which is the model, to query our collection. So let's go into Robo3T. Inside the articles DB, we see that there are a list of collections which is currently empty, 0. So right click and create a new collection. I'm going to call the collection articles like this with a small a. In fact, all the letters should be small. I'll create it. So now click on collections, click on articles, then view the documents inside our collection, and you see that there are no documents. So we need to add a list of documents, and the documents in this case refer to a list of articles that have the title and the contents. I already have them here in this file that I created. I have a list of 5 articles, each one with a title and a content. So I will just copy everything, just copy it like this without the squares. Then I go to Robo3T, click on the articles collection and insert document. So I'll remove these 2 and just paste in everything, and I save. Robo3T is very dull. It doesn't know how to automatically re-update, so I need to query again by viewing the documents again, and voila, now I have 5 articles, and each article has a title and a content. But behind the scene, MongoDB automatically adds an ID field, which is a string of characters that uniquely represents each article. So we now have 5 articles, which is great. So let's go back to Visual Studio and try to create a route, because right now we haven't created any routes that our users can access. So let's create a route. To create a route, we do app.get/articles. So this means that I'm creating a route to /articles, and I want to define what will happen if a user makes a GET request to this route. So each HTTP request takes in the route and a callback function, which will take in the request and the response like this. Function rec and res, which is short for request and response. And inside the body of this function, I define what I want to happen. So what should happen if the /articles route is accessed? What we want to do typically is that we want to query our database and find all the articles in our database and send them back to the user. So to do that, we use the model which I saved into article and say article.find, which is a mongoose method, find. And here's how we use the method. Let's go back to our slides very quickly. Let's go back to our slides very quickly and see how we access. Okay, so when we want to read or make a GET request, we use the model name .find and pass in the conditions for which we want to find data. That follows with a callback function that takes the error and the result if we do find that data. But in this case, we don't want any conditions. All we simply want to do is find all the articles available in the database. So we go back here and just say find. We aren't putting any conditions, so it just takes a callback function that takes the error and the result. I'll call the result found articles. Okay, so for this function, I'm going to check if there are no errors and found articles has a length that is not an empty, it's not empty. Found articles has a length. If this is true, res the response, I will call the send method. And what do I want to send back? I want to send the found articles. Else, if there are errors, just send back to the user the error message. No, not send file, but just send. So if there are no errors, send back to the user the found articles. If there are errors, send back the error. So let's save and test that out. Save and see if it works. If it works, we should be able to go to localhost for 3000 and access the /articles route. So it's trying to restart. So sorry, my computer is a little slow. Okay, it seems it works now. We can now test it out. Let's open a new tab. Sorry. So say localhost for 3000 /articles. I hope this works. Let's see. Voila! Here are all the 5 articles we have in our database, which shows that our server code is working. And I have this really awesome extension. I think it's called JSON formatter, and that is why this is displayed in such a beautiful manner. So that works. That works. So this is good. We can move to the next thing.
Hi, Karen.
So we have been able to successfully fetch all our articles. Now let's make a post request to the articles route, and that post request creates a new
Can you
article.
hear me?
Now here's how we do it. To create a new article, we need to create a new constant that will be an instance of our model, then passing the field names that correspond to the schema, how we defined it, and passing values for those fields, and then we save that new article. So let's do that. Come down here and create a post request. So app.post in this case, and where are we posting to? Posting to the same /articles articles route, and this takes a function with a request and a response. And what we want to do now is to create a new constant. So let's call it new article, and it's going to be an instance of the article model, new article, like this. Now the title, remember that we defined in our article schema that all articles should have a title and a content field. So our title in this case is going to be what the user enters in as the title, and this is where body parser comes in. All requests have an object which is stored inside the request.body. So we can access the title field from request.body and also the content field from request.body. So we have this title goes to request.body.title, while content goes to request.body.content. And after doing this, I will call the save method on the new article, which will save it to the collection of articles that we already have. And save itself takes in a callback function with an error. So save function with an error, and what do we want to do? We are going to have an error check. If there are no errors, then let the user know that the article has been successfully saved. So rest.send like this, article successfully saved to database. Else, if there were errors, just return those errors. Rest.send errors. Let's test out our post request. Let's start the server again. Let's test our server again. Restarting. See.
Can you hear me?
Oh, I'm so sorry. My mic was off. Can you hear me now? April and Nadide. So it seems like my okay, Rafna, are you back? It seems like I've used up my time.
It's okay. It's okay. We are running out of our time. So our closing remarks are on the live stage now. So,
okay. So what I'm going to do is I'll drop a link to it's actually here. Let me just show you the link to the final. We still have about some slides to go, but here's the link to the finished repository, so you can just check it out at your leisure. And if you have any questions, we copy this. I'm going to paste it in here.
yeah.
If you have any questions, just reach out to me. And
Oh, okay. Now, if you can share your, where they can connect with you to ask for you, further questions,
okay, let me
that would be
share.
helpful.
Yeah. So you can access everything here. And first, thank you so much for listening. I really appreciate it. If you want to connect with me, you can send me a DM on Twitter. Here's my username. You can connect with me on LinkedIn. You can send me an email via my website or on GitHub or on Instagram. So just feel free to use any of the above methods. Thank you so much. Thank you, Rafna. Thank you, everybody, for
Thank
being here.
you. Thank you. It was a great session. You really explained it so simple and with examples. It was so much clear. So we don't have time to take any questions. I don't think we have so many questions coming in here. Someone asked that whether you can share the documents, the presentation documents,
Yes.
with them. So yeah, so you can contact Karen through her Twitter, website, GitHub. So anyway, she will be happy to help you with that. Let's rejoin the live stage where we're having closing remarks from Candice Morgan, Google Ventures. So see you there then. Bye, everyone.
All right. Bye, everybody. Thank you so much.